Hello and welcome. My name is Tim, and for 3 weeks I work on a tugboat like this, and then I have 3 weeks off and I hang out on a boat like this. Actually, this boat. I bought this boat a few years ago, and since then have been sailing it up and down the east coast of the U.S. and into the Caribbean. We've been fortunate enough to put about 6,000 miles under the keel in the last few years. And these are some of the things that I've learned in that time. Stick around, I hope you like it. Apologies in advance for the flow of this video, but in here I wanted to show you a couple clips of things that we've done to make some improvements in the hydronic heater plumbing. A lot of people want to see how that worked. Serpentine belt and cooling, how I blow cold air onto the alternator. Sound down insulation, engine room lighting, VHF splitter, Victron servo display, and a problem, not a problem, but something I'm dealing with my electrical panel. So hopefully you two will find it fun. Here's a better look at the serpentine belt conversion. And any of you that are thinking that you're going to put a 170 amp alternator on, you have to understand that a V-belt does not have the ability, because of the surface area, to turn that big an alternator if it's loaded up all the way. So you need to put this conversion on, and luckily the previous owner did that for me, so I was all good about that. But here is the mess that you can see these hoses. These are the hoses right here that I ran. They go all the way back to the lazarette, and then they tee into here, which is where the hot comes off of here and the cold returns into here. And what happens is I put a check valve in here so that when the hot water comes up here like this, it can't go back into the engine, but it goes through to the hot water heater, and then it comes back here. And if it wants to go through there, it can. But why would it go through why would it push the spring on the check valve? Instead, it would go right back there. And you can feel this is all hot, and this is warm, but it's not transferring to the engine. Yeah, right here, I think that's just from latent heat coming up, and as opposed to over here where it's not going down at all. So these are all nice and cool, but this is super hot. So I had a you can see that right there where the two connection is. I had a check valve there as well, so that when the engine started, it wouldn't blow stuff through the heating loop over there, you know, going back to the hot water heater, not the hot water heater, the hydronic heater. Unfortunately, in looking for the reason why I wasn't moving enough fluid, it turned out it was really because there was an air bubble. I ended up taking that check valve out. It was just like this, and with one check valve in here, that's all I really need. In fact, I don't really need any. I could heat up the engine, but I'm just saying the engine provides a lot of extra unwanted heat to the aft stateroom. So if I was in the Caribbean and you were sailing with us for a week and we were in a beautiful little spot and we weren't running the engine, it would be nice to have hot showers and all that, and it'd be even nicer if you didn't sweat at night because you had this block of cast iron that's just radiating heat to you. So that's how that works, and well, or in my case, that's how that doesn't work. So if you have any ideas, let me know. So sometimes when you're filming these things, you think you hit the button and you do everything and you record everything, and then when you get done, you hit the button again thinking that you're shutting it off, but you're actually turning it on because you never did in the first place. That's what happened here. But I was able to grab a still from as I pulled the camera away. What you can see here is a 3-inch blower duct that I brought underneath the engine and up to the back of the alternator. And it's important to know that a lot of these marine alternators, unlike a car that will pull the cooling air through the front, meaning where the radiator is and where the pulley is, and it pulls it through the front of the alternator, the marine ones usually have the fans that pull it in from the back and push it out of the front. So I have a bilge blower back in the lazarette that pulls nice cold fresh air in and blows right there. And what happens is I have a temperature sensor on the alternator, but if the temperature sensor gets to a certain set point that you set in the regulator, it reduces the field down to 50% so that you don't burn up the alternator. So I had this set up so that when you turn on the ignition of the engine, the blower starts and everybody's happy, and that seems to be working pretty well. So now I'm just on the other side of the engine, just so get another look while you listen to me talk here. But I had a choice to pull hot air out of the engine room, which would normally be the way to go, but my primary purpose, because the boat's been running for 22 years with a very hot enclosed engine room, like you can see here, my primary purpose was to cool the alternator. So by bringing hot engine air out of the engine room, you'd still be bringing ambient heated air into the back of the alternator. So I wanted to bring fresh, cool air to the back of the alternator and do it that way. The only and I don't really see that being as a problem, other than that the waste heat, where the air is going to go, other than going back towards the lazarette, which I don't have a problem with at all. Some of it may escape into the aft cabin or into the salon, and you want to keep all that cool, meaning just for comfortability. I don't really see that as being a problem. And when I finish my my insulation here, here's the problem that I have. We've got all this insulation from here all the way up around here, but we are waiting for a new strip from Sound Down. You can see this is the 1/4 inch stuff that I'm replacing, and you can see how it's all dissolved. And there's the air cleaner right there, and it's really that flame guard. There is no air cleaner, and I've got 2 different air cleaners and tried to put them in there, and I believe that they produce a there's too much of a restriction. We're starting to smoke there. So I think the only, I've talked to a couple people, and they say that they like, some people hate K&M filters, but other ones say that they put a K&M on there and it's working fine. But anyway, Sound Down sent me a new sheet of Sound Down, and they sent it to Florida instead of sending it to Rhode Island. So we're trying to work on that to finish this. So we'll have to take this off and that side over there, and then do all the little pieces in the corners and all that, and we'll be all done. But we're going from 1 inch to, actually I can even show you the difference. Yeah, so we're going from this 1/4 inch old insulation that was being vaporized and getting sucked into the intake, and what I believe was the cause of the silicon, not silicone. I had been I have to send a shout out to my buddy Sean, who pointed out it's not silicone in the engine, it's silicon. And one of my buddies, Rick, told me that the silicon is part of the fire retardant that they put in this. All stuff that we don't want to have in the engine. But anyway, this size is being replaced with something this thick. And so not only does it have the thermal barrier on the back, sound barriers here, but it's also got the heavy duty vinyl core in the middle. So I'm thinking it's going to be as good as before, if not better, but we're just waiting for the Sound Down to hook us up with that. And so that's that.
So let me pause this just for a second and tell you a little story. I originally bought my kit from Defender, and I used to be a big Defender fan, but apparently Defender sold out to some Canadian company, and I don't really believe it's the same place that it used to be. I used to really like them, and they were really helpful and really great, and I haven't found that to be, I mean, they're still a very good resource, but I don't think they're the same. Anyway, after I bought my kit, I needed another piece of Sound Down. They didn't have it, and I went right to Sound Down manufacturer themselves, and they sold directly to me. They ended up shipping it to my billing address, and I called them and said, I won't even be back in Florida until this fall. And they were so cool, they just immediately sent one out to the right address. And in this day and age, it's really cool when you get that kind of customer service. So way to go, Sound Down.
Where's Mom?
Oh, so another thing that I didn't talk about is I put all these light strips. I put 2 light strips here and one under the engine, so that you can see if any oil or antifreeze or fuel drops in below. I also put this door switch in, so you don't have to reach in to turn on the lights, but lights will come on automatically through the LED strips. So under here, behind there, is my AIS 800 black box AIS with a splitter in it that went to that radio. After I took that out and put the AIS antenna, dedicated antenna in there, I followed the line down, and I found this all the way, I don't know if you can see it back there, got all this stuff out of here, crawled in there, snuck through, and I found an AM FM splitter for back in the old days when people used to listen to the radio. Taking this out seemed to be where the big problems have been. And I have not had any problems since then. The radio has been working extremely well. In fact, I was coming out of Block Island this morning, and Captain Charlie Jonas, a pilot I used to work with ages, I heard him making a security call all the way down to the race. And normally that wouldn't be a big deal on a VHF radio, but channel 13 is a low power channel. He and I talked back and forth on 13, and I was just like, wow, I guess the thing is working pretty well. So that's what it was. So that's another upgrade. So here's my Patron system, and it's the 7-inch display. And right now we're pulling in 725 watts from the PV array, where batteries are 89%. And we're putting in, well, it says we're only putting in a few watts because most of it's going to the AC loads right now, because we're making it when we got the ice machine working. But our inverter space is at 84 degrees. Our freezer is at 26 degrees. I've been in there messing around. This other one that says battery is not real. This is a real one. This is on a battery lug on our battery space for the batteries. This one right here is just because my Bluetooth Ruby puck is buried under all the stuff in the fridge. I mounted the one in the freezer, but I haven't mounted the one that goes to the bottom. So when it loses its signal, it goes back to battery for some reason, but it'll come up and say the refrigerator temperature once we move something around in the fridge. But anyway, that's how that works, and it's kind of nice because we can come in here and we can turn the inverter to invert only or to the charger on, and that's important if you want to run other loads on the panel that because when I'm charging off of this, I'm pulling like 2.4 kilowatts off, or 2.2 kilowatts off of the inverter to charge the batteries when like the generator's running. So in that case I would put inverter only, and that's how that works. So, and then it will say the generator or line 1 or line 2. If when you connect, it automatically senses that and puts it in. But one of the problems I'm having is something that I'm going to deal with over here. This is my panel. Obviously this is the DC panel and this is the AC panel, and bear in mind that both of these were designed and built in 2002. And people's electrical needs have changed, and Lord knows with everything on this boat, the electrical systems have changed. So back then, there was never a possibility of heating your hot water and running your air conditioning ever on your batteries. They didn't even have an inverter that would be that strong. So they actually have over here, when you put line 1 in, which is 130 amp line, and then line 2 is another 30 amp line. When you put one, you know, you can do that, and these are all lockouts. See how you can lift that up and you can put on snap the generator on here if you want, or you can put the inverter in. This inverter right here, the way that the new inverter is set up, it doesn't seem, the new inverter has been put in with a fail-safe, but let me get back to that in a second. Right here we have the ability to parallel the A and B buses, or line 1 and line 2 together. So when we do that, we can't, you know, we still we don't want to burn up a 30 amp line, but everything's all fused for 30. So an example, my generator can put out about 42 amps. I need to change this breaker, and it's a double breaker, so I need to change this double breaker out to a 40 amp 110 or dual pole breaker, and then increase the wire size to 8 gauge and run it all the way back to the generator. And I haven't got around to doing that, and so in that I'm going to leave this. So what happens now is if I bust the two of these together, I can still only have a total of 30 amps going through, or trip the breaker. And that's a good safety measure to have. Once I get that done, I can bust the two of them together and have up to 40 amps before it trips the breaker. And that's 40 amps at 120 volts AC. Anyway, over here, this is bus A and bus B. Basically, bus A is everything. Bus B is only the air conditioning pump. There's one pump, circulating pump that you know circulates the salt water, and then the aft air conditioner and the front air conditioner. And both the generator and busing through here and the inverter, I'll tell you how I tested it with the inverter, but anyway, you can, the starting load we have enough power to do everything so that it can start all these with the compressor starting. And here's the water heater down here. I have snapped off at the moment. So here's the problem that I have, is that when this system was built, since they never wanted the water heater to ever run, or anything on bus B to run on the inverter, because with 6 AGM batteries, and I think they had like a 1500 watt inverter or whatever, you'd max out your inverter and you burn up your batteries in like no time at all. You're trying to you'd have enough power or enough power in your batteries to take a hot shower, and then you wouldn't have any power for the rest of the night. So they made it dummy proof by not allowing you to do that. Now I've had this out and I've been trying to figure out how they'd use the dumb logic to do that. And what they did is they're not using the input from the inverter on this switch right here. What they do, because the inverter has a line in and a line out, so that when you're either getting power from the generator or line 1, the inverter has that as an input and can charge the batteries or pass the power through like an uninterrupted power supply, and it matches the frequency. There's no flicker of lights or anything like that. But then what they do is they bring the inverter power over here on this bus, and they do everything up to the water heater. So all of the inverter is charging this. So right now we have the port outlets, the starboard outlets, and the microwave. All of that is working off of the inverter, and that's fine. My problem is that if I turn the water heater on, nothing happens because it's not connected to that. Now when I had this out and trying to figure out the logic behind it, I realized that the inverter, the output of the inverter, which should go on one side of the breaker here on the inverter, and to make the inverter go, you have to go and lift the lockups off, so you can't put the generator on, or you can't put the shore power on, and then you snap that over. Well, if I move the output from here over to here and parallel the two, it'll run the ACs. And I've tried that and it works. It also runs the hot water heater. The problem is it doesn't run any of this. So what I think I have to do, and I didn't want to do it like an hour before our guest shows up. I don't know if you can hear, but Crystalita has some family over here, and I figured if I was going to blow up the boat, it shouldn't be an hour before our guest showed up. So when I was successful at moving the output of the inverter from bus A over to the inverter and snapping that on, getting the hot water heater and the air conditioners to work, but losing all this, I said, all right, let's quit while I'm ahead, and I put everything back to normal. So now all this is running, but none of this stuff will work right now. You can see the lights they're not available or anything like that. So my plan is, and I just have to check, I have to map this out. The way my mind works, I have to go and draw this out to think. I believe that I can put on the output of the inverter, on both the hot and the cold, the hot and the neutral, I can put the main output to the inverter side over here, and also run a jumper over to here. But I have to make sure that that's not going to backfeed when there's power on shore power 1 or the generator. That's when the power goes back into the inverter and either acts as a pass-through or a battery charger. So that's something that I'm a little hesitant to do, because I'm not the brightest bulb in the circuit. And I really wish one of you electrical engineers or electricians out there would say, hey Tim, you got some beer? Come over. We can drink some beer and have them blow up the boat for me. Anyway, wish me luck.
If you hung in through the whole video, through all this technical garbage, God bless you. Thank you so much. Really appreciate you watching. Big shout out to my patrons. And if you'd like to buy me a beer, go ahead and hit that super thanks button. Thank you guys so much for watching. Take care. Be safe, and I'll see you on the one.